Hello guys, I am Hariharan J from second year EEE department from Kumaraguru College of Technology, Coimbatore. In this video, we are going to see a simulation of car black box using microcontroller PIC16F877A, which was done by me during the internship offered by Emertxe Technologies, Bangalore, on embedded systems. Now we can go. Introduction about the black box. Black box is basically an embedded system that helps us to record the events that occur in the car. For that I used PICSIMLAB, which is a virtual emulator, and I used a PIC16F877A microcontroller. And for programming that controller I used embedded C programming language. Um, for this project I used MPLAB X IDE, which is a MPLAB X integrated development environment, which is an expert highly configurable software tool which helps us to debug and qualify the embedded designs. And on the left side we will see the PICSIMLAB uh, simulation pic, which is taken from PICSIMLAB, which is used to flash our hex file in it, and we can see the simulations. Now in the embedded C, it is a very popular programming language which is used to program the microcontrollers and the microprocessors. It is highly reliable and easy to learn, and it is very speed in compilation. And we are moving to basic structures of C program, which was teach to me during the internship. um, in the first basic structure starts with documentation section, which is basically the commands, then the preprocessor derivatives which we want to import while starting the program. Then we can declare the declaration of the global variables, which can with these variables can be used in any part of the program. Then we are moving on to the main function. We have to declare the main function and the main work which can be done by the microprocessor are given here. Then we can give the user defined function where we can define other functions of the microcontroller. Then we are moving to the data types. There are many kind of data types in C language. Here I gave the main four: int, which means integer, character, char, float for decimal values, and a double for also decimal values with the large numbers. Then we are moving to operators. There are basically three type of operators: unary, binary, ternary. Binary is a special case. Ternary is a special case. Unary basically had one operand, for the which reason it is called as unary, like a plus plus, which is equivalent to a equal to a plus 1. So we are called it as unary operator. Then binary is divided into five types: arithmetic, relational, logical, bitwise, and assignment. Arithmetic use two operands, that's why we will call it as binary operators: a plus b, a minus b, like that. Relational means a less than b, a less than or equal to b, like that. Logical is basically and or not, like that. Bitwise operator for bitwise operations at the bit level. Assignment operator is used for assignment: a equal to b, a is assigned with the value 5, like that. Ternary operator, it is a like that I said before, it is a special case. Before the question mark which condition is given is um, checked. If the condition is true, the given stuff below the behind the colon is executed. If it is false, the given steps after the colon is executed. Then we are moving on to the conditional operators. There are five types basically: if else, while, do while, switch, and for. I used these conditional structs to build my project. Then we are moving on to the array. It is basically the collection of same type of data items stored in the contiguous memory location in the CPU. And it is denoted using the square brackets. Pointers, it is basically a variable which can store the address of another variable. using ampersand and all. Functions, the user defined functions which is used to perform a task other than main function. It can be passed through value or by reference. Then we are moving on to the embedded systems. Any combination of hardware and software intended to do a specific task can be called as an embedded system. For example, manufacturing equipments, domestic appliances, we can overcome lots of embedded systems in our day-to-day lives. Then we can see the type of embedded systems. There are mainly four types: standalone embedded system, real-time, networked, and mobile. Standalone embedded system, it is a system that works by itself and does not need a host. It can work itself, it can do its work, not others. For example, camera modules, MP3 players, like that. Real-time embedded system, it gives the output in specific time, so it basically follows deadlines to complete the task. Network embedded system, it is interfaced with some networks like LAN, WAN, MAN, etc. Mobile embedded systems are portable embedded devices like mobile phones, digital cameras, MP3 players. Then some of the real-time aspects of the embedded system. Hard real-time, it is obtained, it is the if the result is obtained after the deadline, the system is considered to have the failed completely and it is life crucial. The embedded systems which are related to life crucials are called real-time, uh, hard real times, like pacemaker, ABS, like that. From real time, it is similar to hard real time, but it is not life crucial, like moon rovers, satellite based tracking, etc. Soft real time, if the result is obtained after the deadline, the system is considered to be the success, like ATMs, cell phone, mobile communications, and all. Then we can see the difference between general purpose system and embedded system. General purpose system, it is mainly to perform too many tasks, but embedded system is dedicated to only one task. And the general purpose system, they are designed for the device can interact with a variety of members, variety of ways. When designing an embedded system, manufacturer will focus only a dedicated task only, not to perform all. Then we can see the components of embedded system. There are mainly six components: the power supply, which gives power to the microcontroller, then its memory, then the timers for accurate timings, then its communication port, GPIO ports, then its output and input modules. Now we can see elaborately about the microcontroller. It is basically small and low cost microcomputer which is designed to do a specific task, like which was in a washing machines, microwave ovens, like that. It consists of CPU, timer, GPU ports, memory units like RAM, ROM, and other peripherals also. It is the PIC16 F877A architecture. It is the this microcontroller is using in this project. It is basically built by microchip technology. It has 35 instruction sets. It operates at 20 megahertz frequency. Its operating voltage is 4.2 volts to 5.5 volts. Yeah, then we are moving on to the LED light emitting diode. There are two pins for giving it supply: VDD, which is the anode, then ground pin. Another one is ground pin. There are lots and lots of things inside it, like LED chip, refractor tray, epoxy resin lens, etc. Then we are going to see about a CLCD, character liquid crystal display. It can display all the axis characters and some special characters. There are two types of communication mode in it, that is 4-bit mode and 8-bit mode. CLCD, for interfacing a CLCD with my microcontroller, I want to first note about the pins available in the CLCD. The pin 1 is the ground pin, which is connected to the ground. Pin 2 is connected to V. VDD, which is the input pin. Pin 3 is connected. Pin 3 is connected to control the contrast of the CLCD display. Pin 4 is the register select pin. If we pass 0, to it, the 8-bit data line as instruction line. If we pass 1 to it, it will take 8-bit data line as data to print the CLCD. Then CLCD pins continuation. Pin 5 is the read write pin. If we give 0 to the pin, it will write the data. If 1 is passed, it will read the data. Pin 6 is to activate the CLCD. Pin should be set as high, always be high. Pin 7 to pin 14 are 8-bit data lines where the instructional data is pressed. Pin 15 is the anode, pin 16 is the cathode. This is basically to control the backlight of the CLCD. Then methods to use CLCD. There are two methods, delay method, pooling method. After passing the data is given and then next set of instruction is readily passed, which is called delay. There is a delay between them, so it is called delay method. After passing the data is been read. If it falls to 0, then processing is done. Then the next set of instruction is ready to be passed, which is called pooling method. By using these two methods, we can interface a CLCD with our microcontroller. Then we are going to see about tactile switch. Tactile switch is a component which allows control over current flow in the circuit, which is basically to on or off the circuit. Tactile switches are critical components in the circuit which is required for user interaction. By using it, we have to know two concepts: edge triggering and level triggering. Edge triggering, if the switch is pressed, the signal is passed to only once. If the tactile switch is pressed for once, the high line is went to low for a second, then it will come back to the original state, which is called positive level triggering. If it done in opposite, like if the line is low, if we press the button, then it will go high and come to low, it is negative level triggering. After that, the uh, edge triggering, if we press the signal is passed continuously after the even a single switch. If the line is high, if we press the button, then it will go and go to 1 and stays there. uh, Once the next triggering is occur, that is called level triggering. Like volume button in TV. Now we are going to see about the bouncing method. When we close or release the tactile switch, it will tend to literate the bounce upon the method contact. This method is called bouncing effect. Like that, we can see if unpressed state means 0. If we press it, the first wave is here, but the voltage is still uh, bouncing front and back, 5 to 0, 5 to 0, 5 to 0. For that, the voltage is not steady. It will mostly occur about 20 to 50 milliseconds in a normal tactile switches. Then we are moving on to the interrupts. Interrupts is basically a thing which interrupts the normal process. The microcontroller, yeah, works on a normal work which is given in the main function. When the interrupt occurs, with the help of ISR function, interrupt service routine function, the microcontroller CPU function was interrupted, then it was redirected to the ISR function. Then it will start executing the steps present inside the ISR function. After executing those steps, it will return back to the original process and it start executing the things given inside the main function. There are two types of um, interrupts: software interrupt, hardware interrupt. Software interrupt is basically the interrupts given by coding. Hardware interrupt, it is caused by external or internal device. The hardware interrupt is further divided into two types: maskable and unmaskable. Non-maskable interrupts are interrupts that cannot be disabled by the CPU, but maskable interrupts can be disabled or ignored by the CPU. Then we are moving on to the main topic, timers. Timer is a specialized clock which is used to measure the time intervals. The width of the register of the timer is called resolution. Each up count and down count is called tick. Measure of time which is responsible for tick is called quantum, which is mainly used to generate PWM, pulse width modulation generator. Then we are moving on to the matrix keyboard. Here we use 4 into 4 matrix keyboard in this project. It is connected with the rows and column lines. It is used to give inputs to the CLCD display. Now we can see the simulation of car black box in the PICSIMLAB. Project codings I had done in the main C for one things I gave uh, each C files. We can see the simulator here. It is called PICSIMLAB simulator. The microcontroller used in this project is PIC16F877A. Yeah, I had already flashed my hex file. In the dashboard, we are seeing the event. We are seeing the event time and the speed. By using the potentiometer, we can adjust the speed up to 99. Then we can also change the event by using various keys given here. Now it is changed to GN. Now we are moving to the login page. For that we need to give the password. I am entering the password. After that we had redirected to the main page. Here we can see view log, clear log, and change password. First I am going to see the view log, the event which was given there. The first event we had changed the event, then it was captured also. uh, then we want to we are going to clear the log. I can select the clear log. Log is all logs are cleared. Then I am going to change the password. For that I need to select change password, and I will give it the new pass. I am entering the new password. The password is changed successfully. Now we can enter the new password, whether it is working or not. I am giving it. Yes, it is working. These are the things I had done in my internship offered by Emertxe Technologies Bangalore on embedded systems. I had learned a lot of things from this internship. Thank you for giving me this wonderful opportunity to participate in this internship. Thank